Okay, all right, so we have molecular geometry. As you can see, we have the molecular geometry can be the same as electron geometry, but it can also be different. Okay, so kalau dia different, it means that the molecule consists of lone pair. Okay, all right, for example, we have tetrahedral kan, so we have molecular geometry, tetrahedral as well, but we also have trigonal pyramidal and band. Okay, for the same electron geometry. So this means trigonal pyramidal and band shape consist of lone pairs. Okay, and same goes to trigonal bipyramidal and octahedral. So we have discussed about this yesterday. Okay, yep. And you have been introduced to bond angle also. Okay, so bond angle means the angle between the bond, and then the arrangements of lone pair, bonding pair, and bonding pair repulsion. Okay, so the lone pair repulsion has is more dominant. Okay, more dominant as in it is. The repulsion is the largest or the highest compared to bonding pair and bonding pair, and also bonding pair dengan lone pair. Okay, alright. Okay, so we have covered the linear electron geometry, and trigonal planar also covered. Okay, and tetrahedral also we have covered this in yesterday's lecture. Okay, all right, so now we're going to start with trigonal bipyramidal. Okay, ready? All right, so electron geometry for trigonal bipyramidal. This electron geometry consists of 5 electron groups surrounding the central. Okay, all right, so we may have molecular geometry. Okay, we may have molecular geometry the same as the electron geometry. Okay, so molecular geometry can also be trigonal bipyramidal. So in this case, for example, look at the diagram that we have here. The diagram example of molecule. Okay, so as you can see, all of the electron groups are bonding pairs. We have 5 bonding pairs, or 5 still. Okay, we have 5 electron groups. It's just that all the 5 electron groups are bonding pairs. Okay, all right. So trigonal bipyramidal ni dia tricky sikit. It's a bit tricky compared to others that we have learned earlier. Okay, because it consists of two bond angle, guys. Okay, so it become more crowded. So trigonal bipyramidal means we have 1 extra atom ataupun 1 extra lone pair compared to tetra. Bukan lone pair, 1 electron group. Okay, 1 extra electron group compared to tetrahedral. So they become more crowded juga situ. Pasal tak? Nampak tak? So the space is now become limited. Okay, sebab dia kena accommodate all the 5 electron group. So the best ataupun the most ideal ataupun the less repulsion that all the electron group can be is in this trigonal bipyramidal. Okay, so trigonal bipyramidal can be divided into 2 parts. Satu dekat kawasan yang bulat ni. Okay, this is like trigonal planar, guys. Trigonal planar. Dia ada 3 and then dia flat. Okay, so that will be the center. So this is what we call equatorial position. Equatorial, like our khatulistiwa punya tu kan, equatorial kan. So it is equatorial position. So we have 3 atoms at the equatorial position and 2 atoms at the axial position. Axial means dia tegak. Nampak tak straight ni? Ni straight ni, that means these two, okay, this straight line is considered at the axial position. Okay, all right. So equatorial and axial position. So of course they both have different bond angle. Okay, all right. So tunjuk. Okay, so this is how, nampak ke? Boleh nampak ke? Seorang boleh respon? Someone please respond.
Nampak.
Okay, nampak clearly Alright, so this is how trigonal bipyramidal looks like. Okay, we have the center and then we have this equatorial part. Nampak tak equatorial part dia? Kalau saya letak dekat atas tangan saya ni, okay, dia flat. Dia sama macam this one. This is trigonal planar kan? It's actually the same guys. Dekat tengah tu equatorial. Okay, it's actually the same. Abaikan yang atas lah. Okay, it's actually the same. So this is the equatorial part. As you can see, we have 3 atoms there. Okay, and this straight linear part yang tegak ni, okay, is the axial position. Okay, alright. So katakanlah, so this is the same as what we have for in the diagram just now. Kalau saya pusing pun, kalau saya pusing kan, this one saya pusing macam ni. Okay, pusing macam ni. Ni kena pandai imajinasi, kena tinggi sikit lah. Okay, from here to here. Okay, so yang tegak ni will become the straight line. This one, nampak tak? This will be your axial part. It depends on how you rotate the molecule lah. Okay, so this will be your axial part and this one, yang 3 ni, saya pusing begini, nampak tak ada 3. So this is what we call equatorial position. So dia depends lah. Macam mana you tengok. Okay? Alright. So saya nak pegang sama as what we have in the picture, in the diagram here. Okay? So you have the straight line and you have the equatorial position. Okay, so now in terms of bond angle, so you have to mention in terms of the axial and the equatorial position. Okay, all right. So this is how your trigonal bipyramidal. So the angle between the axial, guys, this is straight line, kan? This is axial, and this one is the equatorial. Okay, so this angle is agak-agak berapa ni?
90 degree.
Yes, it is 90. Nampak tak 90? Okay, sebab dia macam L kat situ kan, dia flat ni, nampak kat atas tangan saya. So this is 90. Okay, so this is 90. And then how about between the equatorial bond? Okay, between this one dengan this one. This is 120 guys. Okay, this is also 120, pusing balik, this is 120. Okay, yang dekat tengah-tengah ni 120. But between the axial and the equatorial, this is 90. 90, bawah ni pun 90. This one also 90. Okay. So this is trigonal bipyramidal. Kalau saya nak tunjukkan, let me show you the bond angle on the diagram. This. Okay, kalau nak tunjukkan kan. Okay, so this one. Okay. This one is 90 guys. Okay, and this, ni apa ni? Okay, sorry, tu yang lain tu octahedral. Okay, this one, this is axial, this is equatorial. Okay, alright, nampak yang bulat tu. So axial and equatorial, so this is 90 guys. Okay, look at the diagram Kang duk tengok saya pegang ni, sebenarnya saya tengah discuss the diagram. Okay, the molecular geometry on the slides. Okay, and then this one, equatorial and equatorial here, so this will be 120. Okay, 120. This one also 120. This one yang dekat belakang tu dengan this one is 120. Okay, so this one 90. Between equatorial and axial would be 90. So this pakai color lain lah kan. Nampak dah pening kan ni. So this equatorial with axial, this is 90. Okay, this one with axial and equatorial is also 90. Right? Okay, so imagine, okay, we are done with all the bonding pairs, all the 5 bonding pairs for trigonal bipyramidal. So this is how it looks like. Okay, so remember for trigonal bipyramidal, we have 2 bond angles, 2 ideal bond angles. So this is the less ataupun the minimum repulsion that all the electron group can experience. Ni paling minimum. Dia tak boleh rapat lagi, dia tak boleh adjust lagi lah. Maksudnya this is the minimum. Okay? So the minimum repulsion. Okay. So imagine if we have one lone pair, guys. If there is one lone pair, katakanlah you draw from the chemical formula given, you draw the Lewis structure and then you identify the electron geometry, you kira, you count all the electron groups. You have 5 electron groups, okay? But we have 4 bonding pairs with one lone pair. That means there is a presence of one lone pair dekat situ. Okay, so this is what we call seesaw. Okay, alright. So imagine here. Katakanlah there is one lone pair kan. So remember we have equatorial position dengan axial position. Where should we place the lone pair? In order, remember the target is to minimize the repulsion. The target is to minimize the repulsion. So where should we place the lone pair, guys?
In equatorial position?
Yes, in the equatorial position. Why is that so? Because at the equatorial position, the bond angle is 120. Okay, compared to kalau kita place on the axial, so there would be, they have 3 electron groups dekat situ. So the repulsion would be higher. Okay, kalau kita place dekat any of the equatorial position, okay, so dia akan rasa dua sahaja bonding pair repulsion dekat situ compared to kalau kita place dekat axial here. Okay, so lagi sekali lah saya tunjuk. Katakanlah, okay, let's say I place the lone pair at the axial position. So imagine how many the number of electron group that will experience the repulsion. So we have the equatorial, all the equatorial part will be experience more repulsion for this lone pair placed on axial position. Okay, so banyaklah, nampak tak, dia kena this one dengan this one, this lone pair dengan this one. Okay, the same lone pair akan ada 3 repulsion besar dekat situ with the bonding pairs. So repulsion higher if we place the lone pair on the axial position. But if we place on the equatorial position, okay, on the equatorial position, yang satu plane, satu satah dengan dia tu adalah these 2. Betul tak? Yang axial ni. 2 saja. Tadi yang equatorial tadi dia ada 3. So 3 dengan 2 mana lagi banyak dia punya repulsion? 3 lah yang axial tadi. Okay, so that is why the lone pair should be placed at any of the equatorial position. Okay, alright. So katakanlah saya pilih ni. So this sama tak dengan drawing tu. Okay, so this is how it looks like. So the electron geometry is still trigonal bipyramidal because we still have 5 electron group. It's just that for the molecular geometry is no longer trigonal bipyramidal. It is known as seesaw. Seesaw tu jongkan-jongkit, betul tak? Okay, so maksudnya bila molecular geometry, ignore the lone pair. Okay, please ignore the lone pair, focus on the atom sahaja. Okay, so this is how seesaw looks like. Okay, jongkan-jongkit kan? Saya kata jongkan-jongkit kan? Saya tu tak nampak kot macam ni. Okay, so imagine this is flat surface. So jongkan-jongkit awak macam mana? Cek 1, 2. Okay, seorang naik ke atas ni, seorang naik kat sini. Tak tahu nampak ke tak? Nampak tak jongkan-jongkit saya ni?
Nampak.
So this is what we call seesaw. Okay. So seesaw. One lone pair. Alright. Okay. Angle guys. Angle. So since we have lone pair now. Okay, macam mana tadi? So kita follow drawing dia tu kan. Gambar dia guys tu. So straight. Okay. So this is the axial part. Mana tadi lukis? So this is the axial part. So this one yang saya tunjuk ni. Okay. And then we have the equatorial part. So this is the equatorial part. Okay. Alright. Angle. So this one kalau initially ideally it should be 90, betul tak? So since we have lone pair, so it will be less than 90. Okay. It will be less than 90. Kalau between the equatorial and equatorial, okay, so this is axial and equatorial. How about this one? This is between equatorial, so it will be less than 120, which is this one. Bila you dapat trigonal bipyramidal ni, you kena identify the equatorial position and the axial position. Okay, you do that first because then only it will be easier for you to imagine. Kalau you tak nampak, equatorial kat mana cari yang 3 tu. Okay? Yang spinner, yang kita ada spinner tu kan. So yang 3. So that will be your equatorial. Okay? So that is seesaw. Okay. Seesaw Alright. So next, imagine if we have 2 lone pair guys. Okay? So the electron geometry is still trigonal bipyramidal. It's just that now we have 3 bonding pair and 2 lone pair. Okay, in total still we have 5 electron group. It's just that dia berbeza lah bonding pair, the number of bonding pair and the number of lone pair. Okay, so where should we place the second lone pair, guys? Should we place the second lone pair on the equatorial position or now we can place it on the axial position? What do you think? Is it equatorial or is it axial now?
Equatorial.
Yes. Okay. So it should be equatorial still equatorial. Again, sebab dia punya bond angle dia tu lebih besar compared to kalau dekat axial. Senang cerita lah macam tu Alright, so it should be placed on the equatorial position. Okay, so this is the first lone pair just now. So the next lone pair will be placed any of these two, apa nama benda lah ni? Equatorial position. Okay, so katakan saya remove yang hijau, the dark green. Okay. Alright, so don't forget that electron geometry is still trigonal bipyramidal, but the molecular geometry is now different. It is called T-shape. Dalam gambar tu pun dah nampak T-shape. Okay, sekejap lagi saya tunjukkan how you should draw your geometry. Okay, alright. So it is called T-shape. Okay, ignore the lone pair guys. Ignore the lone pair. So forget about this lone pair. Okay, so what do you see? Okay, ini boleh nampak lebih jelas kot. This is T-shape. Okay, capital T. T-shape. Nampak Tak nampak memang tak tahu nak cakap apa. Ni memang terang lagi bersuluh. This is T-shape. Okay, T-shape. Alright, so abaikan yang ni Okay, so angle guys, angle. So this time around we have 2 lone pair. Okay, alright, we have 2 lone pair and we only have this is T-shape. Nampak juga kat sini. You pusing-pusing macam mana, you still dapat T-shape. Okay, pusing macam mana pun, you still dapat T-shape. Apa nama tu? Angle. Okay, so angle. So now we only have one. Saya buat macam ni lah. So this is T-shape. Okay, so now we only have buat macam ni lah. Macam ni. Sorry. Saya buat macam ni. Okay, sebab tadi kita dah start from macam ni kan. So this is the equatorial part. So now we only have one atom at the equatorial position, which is this one. Yang ni, 2 ni dah jadi lone pair. So this is the only equatorial left at the only atom left at the equatorial position. Okay, so what is the angle between the axial and the equatorial? So it should be
90 degree.
Yes, no, it should be less than 90. Okay, sebab we have two lone pair here. Dia memang dia nampak, yelah, limitation kita adalah bila kita ada model ni, kita kena model pun kena power lah so that kita boleh nampak dia bend kan. Tapi saya punya model ni dia hanya boleh mampu tunjukkan beginilah. Okay, as if dia straight kan, as if dia 90, but supposedly it should be a little bit dia bend sikit lah. Okay, tapi still T-shape. So the angle should be less than 90. Okay, remember when you have the lone pair, so the angle is no longer ideal. Supposedly it should be 90, but now it is less than 90. So this is less than 90, guys. Less than 90, and this is also less than 90. Okay, all right. So T-shape. All right, so if we have one more lone pair, okay, imagine bila kita buat the Lewis structure, from the Lewis structure, we can identify that there are 3 lone pairs on the central. Okay, all right, so we have 3 lone pairs and then 2 bonding pairs. So it is still, the electron geometry is still trigonal bipyramidal, but the molecular geometry is now linear, guys. Okay, again, okay, where should we place the lone pair? Okay, where should we place the lone pair? Okay, this is equatorial again, this is equatorial. So we should place the lone pair on the equatorial position. So kita tinggal satu je tadi kan. So remove the equatorial position, yang atom on the equatorial position. So we are left with linear geometry. Okay, disregard the lone pairs. Okay, only focus only on the atom. Okay, so these atoms are in linear form. Okay, they are linear. The geometry of this molecule is linear. Okay, linear dekat situ. So dekat equatorial are all lone pairs. Okay, so bila dia ada lone pair dekat keliling dia tu, we have the bond angle, okay, from this bond to this bond for the axial position, atoms on the axial position, so we got 180 degrees. Bukan less than 180, it should be 180 degrees. Kenapa? Because they are all equally repelled. Yang this part, yang equatorial position ni, they repel equally. Tolak dekat atas, tolak dekat bawah. Okay, so that's why it is 180. Okay, so banyak sikit lah dia punya derivation of trigonal bipyramidal. Okay, now how do we draw?
Madam,
Yep.
nak tanya kalau untuk T-shape tu, untuk kan kita boleh nampak dia ada axial juga kan, atas dengan bawah tu. So kalau kita cakap angle dia 180 boleh ke?
180 for the axial position.
Okay,
Antara
for the
axial position, it's okay for you to okay, jap. No. Dia tak boleh jadi 180 sebab dia ada lagi dia ada 2 saja lone pair. Okay, this molecule consists of 2 lone pairs only. So by right dia akan push down. Mana tadi? This one kan? Okay. Alright, so macam ini. This one. Okay, kalau dia remove this one, then only kita ada repulsion. Mana tu? So we have repulsion. Lone pair dekat sini, tolak ini. Lone pair. Dia macam circle kan, spherical kan. So dia repel equally tau. Maksudnya dia punya repulsion tu are equal. Tapi kalau you ada 2 lone pair saja, dia tak equal. Okay, it's not equal. So it should not be 180 lah. Dia tak patut 180. After all, dia bukan 90 dekat atas tu. Between equatorial and axial pun bukan 90. Betul tak? Less than 90 kan? So macam mana you boleh dapat 180? Okay, so dia bukan 180, but normally if you were to represent the equatorial and axial, kita akan represent the angle of equatorial and axial. Okay, normally equatorial dengan axial. Kita tak go beyond, maksudnya from axial to axial. unless we are left with this atom saja. So obviously this is 180. Okay, kalau ada equatorial and axial, normally the bond angle is between equatorial and axial. Faham tak faham? Okay, faham so kalau ada equatorial dengan equatorial, then we have to show that between the equatorial punya bond angle. Okay, sebab dia still sebelah-sebelah, faham tak? Dia sebelah-sebelah yang closer lah, closer. Kalau axial tu dia di atas dan bawah kan, quite far lah. Okay, it's quite far. Okay, so kalau you nak represent the axial dengan axial, it should be less than 180 lah. Betul tak? It should be less than 180. Sebab you imagine this one is pushing, this one also pushing, so this one dia akan came closer to one another. So the bond angle, remember the bond angle bukan bond of the lone pair, angle of lone pair dengan bond. It should be the angle between the bond. So bond of this, what we call is axial dengan axial. So what is the bond angle? So it should be less than 180. Okay, faham tak? Akmal tu yang tanya tadi?
Faham madam, faham.
Okay, dengan panjang lebarnya. Apa tadi kat mana? Okay, now kita nak draw. How do we draw? Okay, how do we draw? Okay, imagine we have the Lewis structure. Okay, kita dah ada Lewis structure, and then we have determined the the electron geometry. Kita dah determine the electron geometry. Okay, contoh PCl5 lah, PCl5. Okay, so PCl5 normally you would draw the, kita cut short, saya cut short Okay, sebab saya dah tahu. So PCl tu you akan dapat macam ni. Apa? Madam cuba lukis betul madam. Sekejap ya. Okay, kat mana nak ni? Okay, PCl5. Okay, alright. So, 3, 4, 5. Actually, ni lah patut kita lukis macam ni Sekejap. Tak nak. Normally kan, you guys mesti start dengan 4 tu kan, yang T-shape ni. You start dengan T-shape, lepas tu you buat macam ni. Okay, alright. Sebenarnya benda yang sama So Cl. Okay, and lone pair, don't forget the lone pair. So this will be your Lewis structure. Okay, so count the number of electron group on the central. So we have 1, 2, 3, 4, 5. So we have 5 electron group. So 5 electron group will be trigonal bipyramidal. So the electron geometry is trigonal bipyramidal. Ini imagine kalau kita start from scratch, bipyramidal. Okay, lupa nak cakap. The reason it is named as trigonal bipyramidal is because of trigonal means it has 3 sides. Bipyramidal, the word bi, okay, the suffix used is bi. Bi means dual. Pyramidal means pyramid. Okay, so we have 2 pyramid having 3 sides. Okay, tunjuk kat awak So kat equatorial ni kan ada 3 kan? 3, so maksudnya ada 3 side. Ada 3 sisi. Okay, so ini baru bahagian atas, yang bahagian satu axial dekat atas this part. Now imagine we have the same pyramid at the bottom. Okay, so that's why it is named trigonal bipyramidal. Okay, Habis juga nak beritahu. Okay, trigonal bipyramidal. Okay, so next you are going to transform this Lewis structure into the correct geometry, which is in trigonal bipyramidal shape. So I would highly suggest you to draw it this way. Okay, right? Draw macam ni. So macam mana? Kita buat macam ni. Bintang, nampak tak bintang? Orang. Nampak tak orang? Ni kepala dia, ni tangan dia. Betul tak? Ni tangan dia juga. Kaki. Okay? Telinga. Rambut. Nak bagi awak nampak lah. Okay? So padam balik yang tadi tak apa-apa tu. Okay. Alright. So this is what I would suggest you to draw lah. Okay. So Cl. Okay. Alright, identify dulu which part of the CL, which one is the equatorial, okay? So which one is the axial? So this would be your equatorial, guys. Okay, paling senang go for axial dulu lah. Axial sebab dia straight line kan, so this would be your straight line. This would be the linear part. So this one is the axial, and this 3 is the equatorial position. Okay, all right. So if you were to what do we call that? To label the bond angle, so you should be labeling. So this is the axial. The moment you have, this is the axial, and this is the equatorial. Kan? This is equatorial. Maybe I can replace with another color, the red color. So the red color represents the equatorial. So this equatorial and the blue, which is the axial, okay? So this one is 90, guys. Okay, same goes to this one. This is also 90. All right, so between equatorial and equatorial, so this one yang paling senang lah supaya saya tak overlap dekat situ. This is 120. Okay, this is also 120. So this is also 120. Okay, faham ke tak faham? Faham tak? Tolong respon sikit, faham ke?
Faham.
Very good. Okay, kena faham kan Next week dah quiz. Okay. Alright, so imagine, okay, let's say saya replace this one with A and X lah, okay? Let's make it general. A and X, A, X, 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 X. Alright, so imagine if we have one lone pair, where should we place the lone pair? Like what we have discussed just now, the lone pair should be placed on the equatorial part. So nak place, kita ada 3 ni. 1, 2, 3. So we can choose any of these 3 in order to place our lone pair. For example, saya nak pilih yang dekat atas tu. Okay, saya akan delete this one. Ganti. Okay, I will replace it with a lone pair. What color should I use? So let's use black color. So this is the lone pair, guys. So what will be the molecular geometry? So what will be the molecular geometry for this? Okay, don't forget to delete the line first. For this one, delete the line. So dekatkan sikit lah kot. Delete the line. Yep. Okay, all right. So what is the molecular geometry now? This is what we call seesaw. If you got seesaw, okay, please make sure that you draw it seesaw lah. Okay, kena nampak bentuk seesaw tu. You cakap seesaw tapi tak nampak seesaw pun. Ini nampak T-shape ni, salah. Okay, alright, so imagine if we have another lone pair, so the next lone pair should be placed dekat mana? Again, the equatorial position. So delete this one, ganti dengan lone pair. Okay, ganti dengan lone pair. So this is the second lone pair. So now delete the line. So this is the, alamak, kita dekatkan sikit lah. Okay, so the line is to guide you on where to place the lone pair. Kita ada guide, lepas tu kita padam lah. Okay, nanti confuse pula lone pair, dah lah lone pair, lepas tu ada bond lah. Tak boleh macam tu. Okay, alright, so this is, the electron geometry is trigonal bipyramidal, but the shape, the molecular geometry or the molecular shape is now T-shape. Nampak tak T-shape? Yes, it is now T-shape. Okay, let's say we have another lone pair. So the next lone pair again will be placed on the equatorial part, which is here. Okay, so padam lagi, bond ni padam balik kat sini, dekatkanlah semuanya, segala-galanya. Okay, place them nearer to the central. And what is the molecular geometry now? It is linear, guys. Okay, it is now linear. So we have 3 lone pair. Okay? Alright, so make sure that you are able to draw the molecular geometry. You have to transform your your Lewis structure into the correct geometry, into the correct molecular geometry ataupun molecular shape. Okay? Okay ke untuk Trigonal Bipyramidal before we proceed to Octahedral? Ya Allah, itu saja dah sejam. Nak dekat setengah jam.
Okay.
Okay eh? Okay eh? Okay, doing good. Okay. Alright, so let's move on. Okay, so that's why saya go through very thoroughly with Trigonal Bipyramidal just now. So you dah ada idea on how you should place the lone pair and whatnot. Okay, so the same understanding we apply for octahedral. So now it become more crowded. They become even crowded because we have more electron group. For octahedral, we have 6 electron group, guys. So they become more crowded, sempit lagi. Okay, all right. So 6 electron group can be in the form of all of the electron group in bonding pair. Okay, in all of the electron groups are all bonding pairs, and then we can also have 5 bonding pair, 1 lone pair. They are all still 6 electron group. 4 bonding pairs, 2 lone pair, and then we have 3. Tu yang dia tak tunjuk tu dekat sini 3 bonding pairs. Maybe you can add in 3 bonding pairs, 3 lone pair, guys, and then we have 2 bonding pairs plus 4 lone pair. Okay, so this is already the same. These two are the same as Trigonal Bipyramidal. So we got linear and T-shape later on. Tak percaya, cuba try. Okay, alright. Cuba tengok yang ini. Octahedral. So the shape, if there is no lone pair, it will be octahedral. So this is how your octahedral looks like. Okay, the reason they octahedral, even though they ada 6 electron group, kenapa tak nama hexagora ke? Okay, kenapa it is called octahedral? Okay, it's not based on the number of electron group, it's based on the number of sides. Okay, dia ada 4 sides. Dia ada 4 sides guys tu Alright. So imagine, so dekat equatorial position, tapi kita tak highlight equatorial lah, okay, for octahedral. So on the the circle part, the spherical part here, it has 4 electron group. Okay, 4 electron group. Nampak tak? Kalau ada 4 kat sini. Kalau saya remove kan tengah ni, spinner kita kali ni ada 4. Okay, that means we have 4 sides. Is it? Yeah. Octa kan stand for 8. Kan? Octagon. So octa means 8. So up here we have 4 sides. Kat atas piramid 4 sides. Kat bawah pun we have another 4 sides of pyramid. So in total we have 8 sides. So I think because of that it is called octahedral lah. Okay, alright. So octahedral, so this is octahedral. If there is no lone pair, the molecular geometry is known as octahedral. Okay, how about the angle? As you can see, all of them have a bond angle equal to 90. Semuanya nampak 90, nampak tak L shape tu? Okay, saya pusing dekat, pusing balik. You still akan nampak the same molecule. Okay, semua dia straight line, perasan tak? Straight line. This one up here and at the bottom, so these are all straight line. Yang tengah ni, okay, again straight line. This one and this one, the left and the right is also straight line. So that's why, okay, they are all 90s. All the bond angles for octahedrals are all 90s. Okay, alright, tu senang lah. Okay, next, imagine if we have lone pair. Okay, if we have one lone pair, where should we place the lone pair? Where should we place the lone pair, guys? Where should we place the lone pair if we have one lone pair? Kat mana?
Axial.
Axial. Axial sini. Can we place it here? Any of these 4?
Semua boleh.
Semua boleh. Okay, because now all the bond angles are 90. So you place anywhere pun still juga dia punya lone pair tu still kena place dekat salah satu kan, sebab all the angles are 90s. Okay, so dia tak kisahlah, it can be placed anywhere. The difference between octahedral and trigonal bipyramidal is that trigonal bipyramidal now have two bond angle. Tu yang kita kena jaga-jaga. We have to be careful because we have two angles now. Two bond angles. We have equatorial and axial. But this one, even though dia ada equatorial and axial, tapi there's no effect. Tak ada apa-apa influence pun because the bond angle are all the same, all 90. Okay, you place lah. Kan saya pusing tu, you still get the same molecule kan. Saya pusing pun, you still get the same molecule. Naik atas, sama juga. Naik bawah, sama juga. Kiri, kanan, everything pun the same. Okay, so you can place it anywhere. Katakanlah saya nak place here. So this would be your, this would be the shape of the molecule. Okay, alright. So the electron geometry is still octahedral. Okay, even though it has one lone pair, 5 bonding pair, in total we still have 6 electron group. Okay, alright. So for the molecular geometry, okay, saya nak ikut dalam gambar lah. Saya nak follow dalam gambar. I would remove the one at the bottom here. Okay, so for the molecular geometry, it will be called square pyramidal. Okay, sebab kita abaikan. Ignore the lone pair guys, ignore the lone pair. So as you can see, the atoms part, okay, the shapes are all, the shape is square pyramidal. Okay, square pyramidal, nampak tak? Piramid. Square tu because dia punya bottom dia ni square. Saya padam lah, saya remove this one. Okay, abaikan. After all, kita kan, we will ignore the lone pair. So as you can see, dia ada 4 sides. Nampak tak? 4 segi tu. Okay, so that's why it is called square pyramidal. Pyramidal because it form pyramids up here. Conting lah kat atas ni . Okay, so this is the square. And this is the pyramid. Okay. Alright, so it is square pyramidal. So the angle is now less than 90 because it has one lone pair. So they push. Okay, so push all the bonding pair closer to each other and it causes the bond angle to be less than 90. Okay, cause the bond angle to be less than 90. Alright, so this is square pyramidal. Next. So this is the lone pair just now. Okay, so imagine if we have 2 lone pair guys, where should we place the next lone pair? This time around we have to be careful because the bond angle dia dah lari sikit dekat situ and then we have to be careful. Okay, in order to minimize the repulsion. Okay, alright, so the same question, okay, I'll be asking, where should we place the lone pair? Remember, kita nak place the lone pair tu, kita kena ingat, we have to bear in mind, we have to place the lone pair so that the repulsion is minimized. Okay, so we want to minimize the repulsion. So where could we place the lone pair so that the repulsion is now minimum? Dekat mana?
Across the first one.
Yes, it's opposite
At the
of
top.
this, the first lone pair, which is at the top lah ataupun dekat up here lah. Okay, sebab remember the stronger repulsion would come from lone pair and lone pair. So we try to keep them as far as possible, jauhkan dia. Okay, sebab yang paling tinggi repulsion adalah kalau lone pair and lone pair they sit close to one another. So imagine if you were to place the lone pair somewhere around dekat equatorial ni. Kita place the lone pair dekat antara 4 ni. Katalah saya pilih yang ni lah. Okay, I choose this one. Okay, main guli ni jatuh pula. Okay, so as you can see, this lone pair here yang dekat bawah yang pertama tadi is now closer with the second lone pair. So this is closer. This is not good, not good one, not good. Okay, so this is not good. So it should not be placed there. Any of these four tak boleh place. So we should prevent that to happen. So in order to minimize the repulsion, the lone pair, the second lone pair should be placed at the top. Okay, so dia far away lah, dia jauh sikit, dia ada repulsion tu, but it's not as significant compared to just now. Okay, alright. So molecular geometry, guys. For the molecular geometry, it is known as square planar. Focus on the atomic part. Okay, ignore the lone pair. So as you can see, kalau saya buang lah the lone pair ni kan, nampak apa? You can see square planar. Okay, so this is square planar. Square because it is square, planar because it is flat on a surface here. Okay, so this is square planar. Right? Okay. Macam kanak-kanak tadika lah. Main cantul-cantul Lego. Okay, so this is square planar. So as you can see, you should be drawing the structure as this square planar. Okay, alright. Imagine, okay, dia tunjuk sampai square planar je. Tapi sebenarnya, like I said just now, kita ada ni juga. So imagine if you were to have another lone pair. So the only thing we could remove, kita place the lone pair at any of these four, betul tak? So place lah anywhere. Kan? Okay, so the molecular geometry is now apa guys? What do you see? What is the molecular geometry now? If we have
T-shape.
T-shape.
It's three shape lah, bukan three shape, T-shape. Okay, it's T-shape. Nampak T-shape kan? So imagine, okay. So this is T-shape. So you tambahlah sendiri dekat you punya notes tu. Boleh draw lah how does T-shape look like, okay? Remove any of the green ball in the diagram. Okay. So okay, if we have another lone pair, this time around we have to be careful. Okay, kita kena careful because we have T-shape now. Okay, where should we place the next lone pair? Is it any of these two, green, dark green color, or the lighter green?
Lighter green.
Sorry?
Lighter.
Bawah dah.
Yes, dekat bawah ni, lighter green ni. Okay, so we should place the lone pair, the next lone pair here. Dia tak boleh dekat sini. Tak boleh. Kalau imagine kita place this one Imagine, tengoklah melambat-lambat the lone pair ni. Ni lone pair, this one lone pair, lone pair, lone pair. So you boleh imagine tak the repulsion, okay, experienced by all the electron group. Okay, so it should not be placed there because the repulsion is too high. So, in order to minimize, kita kena guna apa yang ada lah, apa space yang ada, apa region yang ada, whatever available space yang ada, kita kena maximizekan. Okay, so it need to be placed down here. Kalau based on saya pegang ni, so it should be placed down here. So this is our 1 to 4th lone pair. Okay, as you can see, what is the molecular geometry now?
Linear.
Okay, it's linear. Okay, so macam mana nak ajar awak lukis pula ni Yeah, how do we draw so that we could get all this structure, geometry? Okay, how do we Okay. Alright, so I would highly suggest you, if you have decided ataupun you have determined the electron geometry, you have the molecular, you have the Lewis structure and then determine the electron geometry, you have decided that it is an octahedral. Okay, you transform your Lewis structure into this form. Okay, AX6 kan, ada 6 atoms. So I would highly suggest you to draw like this. Remember dia, after all dia satu line kan? Satu line, straight line. Okay, so this one is straight line with this one. Okay, right. This one is straight line with this one. Ada 6 remember ada 6. This is linear and another linear here. Tada! Siap. Okay, saya sangat-sangat suggest you to draw this way. Okay, place X, 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 X. Alright, okay, so imagine if we have one lone pair, okay, by using this structure here, okay, how should we place the lone pair? Okay, before that, this is 90. Everything is 90, okay? Everything is 90. Okay, saya remove. If there is one lone pair, guys, what should we do? Okay, sorry, saya draw balik. Straight line. Okay, alright. So the lone pair can be placed anywhere. Okay, it can be placed anywhere. Katakanlah I choose this here. Okay, to place the lone pair. So the rest are all X kan. Okay, so this is the lone pair. So padamlah. Okay, make it closer, licin sikit lah. Okay, nak bagi dia cantik tu kan. Okay, okay, tak naklah situ sebab boleh je situ. Cuma saya nak sama dengan dalam gambar. Okay, X. Saya place dia here. Okay, place dekat bawah. Anywhere, sebenarnya anywhere. Boleh je anywhere. Okay, you still get trigonal pyramid, square pyramidal. Make sure you dapat lah the shape. Okay, so this is square pyramidal. So kita make it nicer. Okay, erase the line, make it closer to the central. Okay, can you guys see the square pyramidal? Ini pun tak cantik. Nampak ni square pyramidal. Yep, this one. Ta-da! Square. Cantik tak? Okay, alright, square pyramidal. And then imagine if we have two lone pair. Okay, if we have two lone pair. Again, you pakai drawing yang sama. Faham tak? Ni. Apa bintang yang sama ni. Okay? Alright, so now you place the lone pair kan. The lone pair should be placed. Katakan di X kita replace with lone pair. So that's now we have here. And then the second one should be the dekat below lah. Okay, at the bottom. Okay, so make it nicer. Okay, remove and then as you can see, it is square planar. Okay, so adjust from here, guys. Pakai this is your guidelines ataupun your reference so that you could have the other derivative of octahedral shape. Okay? Okay. Alright, question, guys. Any question? Okay, so this is a table that have everything in here. Okay, so this is the electron pairs. Okay, if we have two electron groups, but all of the electron groups are in bonding pair. Okay, there's no lone pair, so it should be linear, and the bond angle is given 180. Example, we also have example BEF2. Okay, if we have three electron group. If all of the electron groups are bonding pair, that means we have trigonal planar. Okay, so this is the electron geometry and the molecular geometry is also trigonal planar. There's no lone pair, okay? All right, what if we still have three electron group, but two of them are bonding pair and then one of the electron group is lone pair. Okay, so it is still trigonal planar, guys. In terms of electron geometry, it will be the same, but the molecular geometry is now different. Okay, so benda ni yang sama as what we have discussed earlier. Sama je, cuba we put all the information in a table. Lengkap, complete dengan contoh. Okay, cuma again, macam biasalah octahedral ni dia tak include yang T-shape and linear. Okay? Alright. Okay ke? Any question before we proceed with example and
Madam, sudutnya kan madam? Kena kira ke macam ada calculation ke apa ke memang dia fix macam tu je?
Okay, there's no calculation because as of now, okay, we do not make it compulsory for you guys to specify the angle, especially for molecules having lone pair. Okay, so definitely if we have lone pair, it will affect the bond angle. Tapi kita tak wajibkan you specify what will be the bond angle. Last time dulu you punya senior, you kena specify. If you have two bond angle, if you have two lone pair, that means it's no longer the same as if we have one lone pair. So you kena specify. Itu dulu. Sekarang what you need to do is to just state that it should be less than 120 ke, it should be less than 109.5 ke. If it's tetrahedral, that means kalau we have one lone pair, it should be less than 109.5. Macam itu saja. Normally dulu kita kena specify 107, 104, 105. Kena hafal lah. In a way kena hafal lah. Tapi now tak payah. Okay, you just state less than 109.5. If it is a tetrahedral electron geometry. For electron geometry, the electron geometry is tetrahedral. So tak ada formula lah. There's no formula. Okay, you kena hafal saja for each of the electron geometry that we have. Okay. Alright. Ada soalan ke? Before we proceed with the example. Ada? Okay Clear? Alright. Punyalah ramai student dekat dalam saya punya session ni, combine 4 kelas. Tapi seorang pun tak menjawab. Okey ke tak okey tu? Okey. Jawab sikit, bagilah Madam awak ni motivasi.
Okey, Madam.
Aduh.
Madam fighting.
Apa dia? Apa tadi? Cakap apa? Tak dengar.
Fighting.
Fighting. Cakaplah fighting ke apa ke kan. Psycho lah awak ni. Ingat saya cakap seorang. Sedangkan 4 group combine ni 4 group S19, S20, S13, S14. Okay. Use the Vsepr theory to predict the molecular geometry and bond angle of the species below. Okay. So let's start from OF2. You kena start from the beginning guys. You have to start from the beginning. Okay, you kena start from the Lewis structure tu. Kira everything. Okay, so katakanlah kita dah skip dah all the kira-kira one. So this is your Lewis structure. Okay, so this is your Lewis structure. Next will be to determine the electron geometry guys. Okay, you have to count. In order to determine the electron geometry, you have to count the number of electron group on the central. Betul tak? So that's why dia punya step number 2 is to count the number of electron group on the central. Kalau saya terus je determine the electron geometry. How do you determine the electron geometry? Count the number of electron group. Okay? Alright. So count the number of electron group. 1, 2, 3, 4. So we have 4 electron group guys. Okay, it will be the electron geometry will be tetrahedral. So next will be kalau dia kat sini identify the electron geometry kan. Kalau saya first Lewis structure and then determine the electron geometry. Okay, determine the electron geometry. Count the number of total electron group lah. Then you got tetrahedral. Next, transform this Lewis structure into tetrahedral shape. So how do you transform this? Remember saya dah ajar itu kan yang tetrahedral shape. So I would highly suggest you to draw this way. Okay, alright. So now kita placekan FF tu, FF lone pair. Okay, nak place anywhere. After all, they are all ideally they have 109.5 degrees. So this is lone pair. Katakanlah saya nak place the lone pair here and here. Boleh nak place kat sini pun boleh, kat sini pun boleh. You still got band shape later on. Okay, alright. So this is F, this is F. Okay. Okay, nampak tak? Dia tak ada, jangan buat, you kena make it closer. Itulah, Madam pun buat line tu bukan panjang ni kan. Okay, make it closer guys. Okay. Based on line tadi, so kita redraw balik, make it closer. So this is how, nampak tak? What is the molecular geometry now? So focus on the atomic part. So this is what we call band guys. Okay, this is band. Nampak tak bentuk band? So examiners will look for this shape, this band shape. Kalau tak nampak band shape, that means kita bagi salah. Okay, how about the bond angle? Okay, remember for tetrahedral, the bond angle ideally that means there's no lone pair, it should be 109.5. So this one, it should be less than 109.5. Jangan main suka-suka dia less than 120, tak boleh. Less than 90, tak boleh macam tu. Kena based on dia punya original electron geometry. Okay? Based on dia punya, yes, original electron geometry which is 109.5. Dah siap. Okay, sama juga AlCl4, this is minus kan, ada, so there should be bracket and charge there. Okay, so draw, so that this is the Lewis structure, and then count, determine the electron group, the electron geometry. So to determine the electron geometry, we have to determine the electron group. 1, 2, 3, 4. So it is still tetrahedral. Okay, electron geometry is tetrahedral. Kena hafal lah, that's why saya kata you have to memorize all the 5 basic electron geometry. Okay, alright, next you draw this structure in tetrahedral shape. Don't forget the bracket. Okay, so how do you draw the tetrahedral shape of aluminium Cl4 minus Al? Okay, macam mana saya ajar tu, ingat yang tu je. Okay, so Cl, 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 Cl. Don't forget the minus. Okay, so what is the molecular geometry? So this is the electron geometry. Dah lukis, jangan lupa pula name the geometry. So the geometry is tetrahedral. Okay, look for the atom. So all the atoms are in tetrahedral shape. Okay, alright. Kita dah lambat lah guys. Saya kena masuk juga polarity. Saya kena masuk juga polarity. So please complete the checkpoint. We will discuss it next week. Okay. Yang penting saya dah deliver the concept and the steps in order to determine the molecular geometry. Any question related to molecular geometry before we proceed to polarity, guys? Okay, make sure that you complete all the checkpoints. Okay. Kalau ada soalan, kita postpone to next lecture. Ada banyak ni contoh for you to practice. We have a lot. Okay? Lemak cepatlah. Ish, jawapan pun terkeluar. Okay, so please be honest to yourself. Practice, okay? Practice tu untuk for your own good, for your own benefit. So kalau you refer jawapan, you perasan, you faham, tapi sebenarnya you takkan faham unless you try yourself. Okay? Alright. Okay, lihat 1 minit. Minum air sekejap.
Besar cawan.
Besar lah. Tahu nak duduk 1 hari, tak topak-topak air. Yang ini top up lebih sikit sebab hari ni kelas sampai pukul 6. 2 kali top up. Sikit lah saya minum air. Okay guys. Bismillahirrahmanirrahim. Polarity of molecules. Okay, learning objective. So we have 2 learning objective for this subtopic. Okay, which is more than Vsepr. So we have to make sure that you are able to classify a bond as being non-polar, polar, or ionic base based on differences in electronegativity. So we will base on electronegativity of the atoms. Okay, and then you have to explain a molecule as polar or non-polar based on the molecular shape. Molecular shape is also known as molecular geometry. Okay, all right. So by now you should know that we have 2 types of geometry. One is electron geometry. Okay, the second one we have molecular geometry. So each of these geometry has its own use. Okay, dia ada kegunaan dia, usage dia ada kegunaan, dia ada kegunaan dia lah, senang cerita So electron geometry, molecular geometry. So for the molecular geometry, okay, we will be based on molecular geometry in order to determine the polarity, guys, which is this topic. Okay, Polarity will be based on molecular geometry. On the other hand, electron geometry will be based on hybridization, which is our next subtopic after polarity. Okay, alright, nampak tak dia berkait. Maksudnya, if your molecular geometry is wrong, definitely your polarity will be wrong as well. Okay, right. So dia macam apa nama tu, rantai lah. Okay, macam berantai. Okay, types of covalent bond. So we have covalent bond. So we have few types of covalent bond. Okay, alright. So if we were to divide the covalent bond into few types, we have polar covalent bond, then we have non-polar covalent bond, and coordinate or dative covalent bond. So this one we have covered. Okay, we have covered this one earlier. So we have these two, polar and non-polar. So let's see what is the difference between these two. Okay, all right. Polarity of bond. So what is a polarity of bond? Okay, covalent bonding between unlike atom results in unequal sharing of the electron, forming a polar covalent bond. Okay, remember electronegativity. Okay, so macam saya cakap tadi, kita akan based on the electronegativity. So this electronegativity cause the difference in electronegativity of atoms will cause the unequal sharing between the atom. Okay, take for example HCl. Okay, Cl is more electronegative. Kenapa dengan more electronegativity itu? Cl is more electronegative as in it has higher tendency to attract the bonding pair. So this is a bonding pair. Instead of they share this bonding pair equally. Okay, but Cl has higher tendency to pull this electron or to pull this bonding pair towards itself. However, they're still sharing, cuma dia tarik towards itself. Okay, so these cause pole. Okay, berlakunya pole kutub. Bila dia tertarik to this side, this bonding, okay, the electron bonding is attracted to Cl. This cause the pole to it produce pole lah. Okay, ataupun dipole. Dia wujud dua kutub dekat situ. Because dia tertarik ke sana, so this side will become slightly positive, delta, slightly positive, and this side on Cl is slightly negative. Okay, kenapa dia slightly negative? Because dia ada extra electron sekarang on dia punya side. So this create pole guys, kutub, ataupun we call it as dipole. Dipole maksudnya means dia ada dua kutub. Kutub positif, kutub negatif. Or we call it partial negative charge and partial positive charge. Okay, so this is what we call unequal sharing. Sebab they have different electronegativities. Imagine if we have Cl and Cl guys. So since Cl and Cl have the same electronegativity, that means they share the electron equally. Okay, sebab electronegativity dia sama. So dia share equally lah dekat tengah tu. So there will be no kutub here, no partially positive, partially negative. Okay, this is not present for Cl because they have the same electronegativity. Okay, alright. So this is what we call the polarity of bond. Bond tu kita boleh tahu dia polar ke tak polar based on this different in electronegativity. For HCl, the bond is considered as polar. Okay, it is considered as polar. Alright, so again, we will be based on the electronegativity values. So in the periodic table, so each of the atoms in the periodic table has its own electronegativities value. Nampak value dia ni? So that will be the electronegativities value for each of the elements in the periodic table. Okay? So across the period, basically it is increasing, guys. Okay? Alright, okay. So how do we classify? How do we classify the bond by difference in electronegativity? Okay, we can calculate we can determine the polarity by calculating the difference in electronegativity. Okay, alright. Katakanlah kalau kita minus difference, maksudnya kita minus lah, kita tolak dia. Okay, kalau kita tolakkan the electronegativity values between for the two atoms, we got it 0. It is considered as non-polar covalent, like Cl just now. So this is what we call non-polar. Maksudnya tidak ada pole, tidak ada kutub. There's no dipole form. So it is non-polar. Okay, because they share the atom, the bond, the electrons equally. Okay, alright. On the other hand, ionic, bila you minus the two atoms, you got the value is more than 2. So that is considered ionic. Dia bukan sharing lagi dah, dia bagi electron tu, the transfer of electron. Okay, so we are done with this one in our earlier subtopic. Okay, alright. If we got a range, maksudnya 0, they're larger than 0 but less than 2. So it is called polar covalent. So this is what we are interested in. Okay, so you kena tolakkan the value. Ini I think this is the ada dua formula lah so far. We have the formal charge and this electronegativity difference. Okay, alright. So we have covalent, which is non-polar, and then we have polar covalent. If it's too different, the electronegativity is too different, beza yang jauh sangat, it will become ionic. Okay, alright. So how do you calculate? Like I said just now, if we have Cl and Cl, so we have to minus this electronegativity. 3 minus 3, we got 0. So 0 means non-polar. Refer this one. Alright, we got non-polar. How about H and Cl? Okay, refer electronegativity there from the table just now, from the periodic table. So Cl, we have 3. Hydrogen is 2.1. Okay, so this is considered quite high. 3 minus 2.1, we got 0.9. So 0.9 falls under, apa nama tu, polar covalent just now. Okay, sodium chloride. Minus this 2, we got 2.1. So this is considered ionic. So this is just to determine the polarity of the bond. Okay, this bond, we want to determine whether it is polar or non-polar. So the obvious one, this is, I mean, more accurate lah. Kita kira, kita ada value. Okay, but normally we would know because we have the trend already kan, across the period, down the group. So we know that H is less negative than Cl. So kalau Cl is more negative, that means kita place the partial negative charge tu. This is partial positive. So if we have this, this is considered as polar. Okay, this is considered as polar. Sebab different in electronegativity. Okay, moving on. Classify the following bond as ionic, polar, covalent, or covalent and give your reason. Okay, alright. So untuk checkpoint 15 ni, you have to calculate lah. Okay, so you have to calculate the electronegativity difference so that you'll be able to know ataupun to justify whether it is ionic, polar, covalent, or covalent. And then you have to give your reason lah. Okay, alright. So calculate lah. Checkpoint 15 ni pun kita akan postpone, discuss later. Laju tak? Okay, any questions so far? Okay, doing good so far? Ayo.
Okay. Okay, so far so good.
Okay. Semangat sikit. Aduh, bila respon tu. Okay, ada semangat sekarang ni. Okay, jom. Dipole moment and polar molecule. Okay, so apa benda dipole moment and polar molecules? Okay, alright. So tadi, okay, what we have discussed just now is the bond, in terms of the bond, whether the molecule is whether the bond is polar or non-polar. Normally, yang kita ada contoh tu adalah simple molecule, betul tak? Between two atoms. Okay, so what we have practice so far, kita ada central, kita ada a lot of terminal atoms. So how do we decide whether the molecule is polar or non-polar? Okay, tadi just nak determine the bond. Now kita nak determine the molecule, the whole molecule, whether it is polar or non-polar. Okay, alright. Kalau HCl just now, simple sebab this molecule is simple. So once it has the bond, the polar bond, that means the whole molecule of HCl is polar molecule. It's simple sebab dia ada dua atom saja. So how about yang ada central atom and then we have terminal atoms Okay, so how do we decide whether they are polar or non-polar? Okay, all right. So before that, okay, chemical bonds are polar when it has one. Okay, macam saya cakap, chemical bonds, the bonds are polar when it has one end partially positive and the other end is partially negative. Macam saya cakap tadi, Alright, so to represent the polarity of the bond, we would use dipole moment. We call it as dipole moment. Okay, guys, dipole moment or mu. Okay, so it's used to measure the bond polarity. Okay, for example, HCl just now. Okay, so we have identified this one is partially positive, hydrogen is partially positive, and Cl is partially negative. So how do we represent this polarity? So we would use this arrow, guys. Kita ada arrow to represent the bond polarity. Okay, so we're going to start from the positive to the negative. Jadilah arrow dia. Okay, so from the positive ends to the negative end. So that itu saya punya suggestion lah. Start from the positive and then negative. Okay, alright. The dipole arrow is used to show the polarity of a bond. Dipole moment is affected by molecular geometry. So the dipole moment is the overall. Ini kita akan masuk vector, guys. Siapa yang tak suka vector tu malang sikit lah. Okay, vector physics. So kita akan apply in this subtopic. Okay, so dipole moment is affected by the molecular geometry. Okay, so what is dipole moment? So dipole moment is the net dipole. Bila kita combine all the dipole moment, so we have a net dipole. Okay, tak payah cerita panjang, tengok contoh je lah. Tada! Okay, alright. So first thing first, you have to have your Lewis structure and then you go through the process in order to determine the molecular geometry. Okay, you dah decide, oh, this molecular geometry is tetrahedral, so the electron geometry is tetrahedral, and then you transform into tetrahedral shape. So this is tetrahedral, The electron geometry is tetrahedral. Okay, alright. So the molecular geometry is trigonal pyramidal. So this is trigonal pyramidal, guys. Okay, alright. So we want to determine whether these molecules is a polar or polar molecule or non-polar molecule. Kita nak determine tu. In terms of bond, dia polar. Tapi sometimes the whole molecule can be non-polar. Okay, so that is the interesting part. Okay, so macam mana nak determine whether the molecule is polar or non-polar? So first step is to determine the polarity of each bond. So kita ada 3 bond kat sini kan? Alright, so kita determine whether dia polar or non-polar. So for each bond, okay guys, okay, so H dengan N. H is more electropositive, N is more electronegative. Okay, so buat color lain lah bagi nampak sikit. Positive, this one is more negative. So it should be, the arrow should be pointing towards N. Betul tak? Alright, so how about this bond here? Same goes to this bond. This is positive and this is negative again. So it should be pointing towards N. Same goes to this bond. Okay, remember, for each bond, you have to determine the polarity for each bond. So you have to draw the dipole moment for each bond. So this is what we call dipole moment arrow. Okay, alright, so when you combine these three in this trigonal pyramidal shape, you combine these three, you akan ada the net dipole moment ataupun vector, satu combined vector pointing upward. Betul tak? Naik ke atas. You combine all of this, okay, you akan dapat combined vector up here. Okay, so this is what we call net dipole moment. Maksudnya, it is a polar molecule if there is this net dipole moment at the end of the day. Faham tak? Okay, so NH3 is considered as polar because kenapa? Because there is a net dipole moment pointing upward. Again, it depends on your structure, your drawing. Kalau you draw ke bawah, that means you punya arrow should be pointing downward. So don't worry about how your geometry tu macam mana you buat ke kanan ke kiri ke. Kita examiners will be based on your geometry. Okay, make sure the trigonal pyramidal lah, octahedral shape ni. So it should be pointing upward. So there is a net dipole moment. So dia punya jawapan, the molecule is polar, okay, because there is a net dipole moment. You dah proof kan ni? Ni, you dah proof? Ataupun you can also answer that the mu is not equal to 0. Dia tak ada siapa yang cancel. Dia ada, this is what we call balance kan, baki dia. Tak ada siapa yang boleh cancel this vector. Therefore it is polar. Okay, alright. So this one dia pointing downward, betul tak? Sama je, you have to identify. This one, this is NF3. This one NH3. Okay, you buat from the beginning and then you determine the geometry and whatnot. So you draw based on the molecular geometry, you dapat this is trigonal pyramidal still. Okay, the electron geometry is also tetrahedral. Okay, so you identify the positive and negative end. So this is positive, this is negative. Okay, so identify this. So dia pointing towards F, outside. Okay, dia ke luar lah. So in this case, when you combine all of this, ada siapa-siapa boleh cancel all of this arrow? Tak ada. Dia combine, dia akan ada combine vector downward, betul tak? So dia ke bawah. So this is what we call net dipole moment, the combined vector. Okay, so kalau dia ada ini, therefore the molecule is polar. Okay. Dah gelap. Sikit lagi. Okay, sikit lagi. Boleh sikit lagi guys. Walaupun saya cakap nampak dah gelap.
Boleh, madam.
Thank you everyone. Okay. Non-polar molecule. Okay. Example. Okay, CO2. Macam biasa gedebak-gedebu apa-apa Lewis structure babu semua sampai dekat you dah draw the molecular geometry. So for the molecular geometry, you got linear shape. You dapat linear shape. It's just that dia double bond. Regardless, 1, 2. So 2 electron group, it is linear shape. Okay? Alright, so now in order to determine whether CO2 is a polar molecule or non-polar molecule, you have to have your dipole moment for each bond dulu. Okay, for each bond, ini remember consider sebagai satu group. So tak payah buat untuk each bond. Okay, alright. So this is considered as one group. So this is positive, this is negative. Alah, C dengan O kan. Of course lah, O is more electronegative kan. So from positive to the negative, and from this one also is negative. So from positive, which is carbon, to oxygen, to the second oxygen. Okay, alright. So dia punya, this is what we call magnitude lah. The electronegativity is what is the magnitude. Okay, so dia pointing different direction dekat situ. Okay, dia pointing different direction dekat situ. So it can be cancelled off, betul tak? It can be cancelled out. So this one can be cancelled out. So is there net dipole moment available untuk CO2? There's no net dipole moment macam yang just now tadi. Okay, because they cancel out. They cancel each other. This can be cancelled out. Sebab they have the same magnitude. Okay, they have the same magnitude. Katakanlah this one is 3.0, this one 3.0. So imagine saya tengah and then ada orang tarik saya kiri kanan. Okay, so orang yang tarik saya tu beratnya sama, tingginya sama, kekuatannya sama. So will I be moving to the left or either to the left, to the right ataupun to the right? No, I will not be moving sebab kepoweran dia sama. Okay, so tak ada, maksudnya tak ada pergerakan, therefore there's no net dipole moment. Itu kalau kepowerannya sama. So imagine if the one that yang pull saya to the right is more powerful than the one yang pull saya to the left. So saya akan bergerak ke mana? Yang kanan lebih powerful, dia tarik saya, dia lebih besar, dia lebih power. Okay, yang kiri ni lemah aja. So dia dua-dua tarik, tapi yang mana saya akan bergerak ke mana?
Kanan.
Okay, I will be moving towards to the right. Sebab apa? Walaupun dia different direction. Okay? Tapi this one is more powerful, so I'll be moving to the right. So kalau case macam tu, katakanlah this one is F. Okay, so we know that F is more electronegative. So katakanlah this one is 4.0. So this one is 3.0. So even though dia opposite direction tapi it cannot be cancelled out. Okay, so dia akan ada net dipole moment to the right. Okay, ni contoh. In case lah kalau dia salah satu tu tak sama. Ya. Okay, kalau dia sama that means it can be cancelled out. After all dia linear provided that it is linear. Okay, linear maksudnya dia simple lah. Okay, so imagine if we have octahedral guys. So this is octahedral. So as we know F this one dengan F this is in straight line. Same goes to this one dengan this one, dia straight line. Linear kan saya dah tunjuk tadi. Okay, so first step first in order for you to determine the polarity, okay, make sure you draw based on the molecular geometry. Okay, and then next you kena draw the dipole moment for each bond. Tu wajib. Kita nampak je ada and the direction is correct, you dapat satu markah. Okay, so you have to draw S is more positive, F is more electronegative, so it should be pointing towards F. So kena ada for each bond. Okay guys, kena ada for each bond. Jangan malas So you have to draw for each bond. Okay, so how do we decide whether this molecule is a polar or non-polar molecule? So the answer is this is a non-polar molecule. Kenapa? Alright, so imagine this is pointing towards F, right? And this one is pointing towards F. So this is in straight line, betul tak? So it will be cancelled out, guys. Okay, it will be cancelled out. Okay, alright. So this one dengan this one is also cancelled out because they are in straight line. Okay, alright. So this one and this one is also straight line. Okay, so they cancel out. So is there a net dipole moment present for this molecule? Ada tak baki dia? Ada tak? Semua dah being cancelled out. So there's no net dipole moment. Therefore, this molecule is tak tulis ke? Mana kat mana ni? Non-polar. Non-polar. Okay? They are non-polar. Even though the bonds are all polar, tapi dia cancel out. Because dia cancel out, kena sebab apa? Dia simetri. Satu dia simetri. And then it is obvious kan? Saya dah tunjuk tadi, dia cancel out tadi. Okay? Due to symmetrical shape tadi. So there's no net dipole moment or the mu is equal to 0. Therefore, it is a non-polar molecule. Okay? Alright, so imagine guys, imagine if we have katakanlah tiba-tiba kan, one of the fluorine is now being replaced with Br ke Cl ke whatsoever. Okay, will the molecule be non-polar still guys? Or dia jadi polar?
Non-polar.
Still non-polar, is it? Dia still non-polar ke atau dia jadi polar? Konsep dia sama tadi macam kalau saya tukar any of this. Dia jadi polar ke non-polar?
Polar. Jadi polar.
Automatically dia become polar. Okay, dia akan jadi polar sebab dia punya magnitude is no longer the same. Okay, it's no longer the same. Kalau case ni, this one, yes, it will be cancelled out with this one sebab dia straight line. This one, it can be cancelled out, betul tak? So this one, the other side, this side cancel out. How about this one? This one, betul dia pointing towards Br. This is also pointing towards fluorine. Tapi siapa yang menang? So kita kena refer electronegativities. So we know that fluorine is most electronegative compared to Br. So it will be pointing downward guys. Sebab ni akan kalah lah. Okay, katakanlah this one is 3.0, this one is 4. Okay, so dia dah overpowered the bromine, so dia akan ada extra dipole moment pointing downwards, which is pointing towards F. Dia akan ke bawah. Faham tak? Okay? Alright. Another example, this is also the same. Okay, tetrahedral. Tetrahedral yang student agak ni sikit. Contohlah CCl4 kan. Alright, CCl4 macam ni ya. Saya kena draw so that you guys boleh nampak. Ini memang vektor ini memang kena vektor lah. Cl. Okay, alright. So macam biasa kita buat the dipole moment first. Kena draw based on geometry based on geometry dulu. Okay, ini remember this one dengan this one, this bond dengan this bond is not in straight line. That's why saya kata bila you draw, you jangan buat ni straight line dengan this one. Dia tak straight line. This is not straight line. Okay, dia angle dekat situ. So, bila you selesaikan vector untuk angle, you kena imagine. Okay. So, nak combine. How do you combine this vector? So, this is an angle. Okay, dia angle dekat situ. So, this one dengan this one, when you combine these two, you nak selesaikan the vector. Okay. These two you combine, you akan dapat dekat sini. Betul tak? Okay, this one cancel, you akan ada baki dekat sini. This one dengan this one you selesaikan, okay, you ni bila you combine the vector you akan dapat dekat sini. Betul tak? So this one dengan this one eventually they are in straight line, okay, and these will be cancelled out. It will be cancelled out. Okay, it will be cancelled out. So still they become nonpolar. Okay, so ni vector lah, ini vector. Okay, if any of this, any of the Cl is now being replaced with hydrogen, automatically dia akan jadi polar. You akan tahu punya, you jawab je dulu polar. So you akan dapat markah dekat situ, setengah ataupun 1 mark. Okay, normally kita nak tengok, kalau you cakap polar, mesti ada this net dipole moment. So kita nak tahu the direction of the net dipole moment. Kita akan based on your drawing. Okay, as you can see, so H ni dia more electropositive than carbon, betul tak? So it should be pointing towards carbon sebenarnya. Dia more positive. This one more positive, more negative. But Cl is more negative. Okay? Alright. Dah habis. Jom kita try buat H2O kejap. Buat H2O kejap ya. Nak bagi kuis nanti takut awak tak ni Alright. So this is the Lewis structure of H2O guys. Okay, this is the Lewis structure of H2O. Saya cut short. Okay, alright. So now determine the electron geometry. The electron geometry is 1, 2, 3, 4. It is tetrahedral. Okay, so next kita akan draw based on tetrahedral shape. Transform this in terms of tetrahedral. So macam yang saya suggest tadi. Okay, hydrogen. Katalah saya nak letak this one is hydrogen. Nak letak sini. Okay, saya nak letak sini lah. Okay, this is lone pair, this is lone pair, lone pair. Okay, adjust, kasih cantik. Dah pula buat. Okay, adjust kasih cantik tadi, macam mana tadi? Sini kan? Dah lupa dah. Okay, alright. So now nak determine whether the water molecule is polar or non-polar. First, you have to have the dipole moment for each bond. Okay, alright. So we know that hydrogen is more electropositive, oxygen is more electronegative. So it should be pointing toward hydrogen. Betul tak? For this bond. Same goes to this one. Okay, label dulu. This is positive, this is negative. Betul ni? Betul. Okay, alright. So this is angle ni ada angle ni. So how do we determine whether this is a polar or non-polar molecule? Okay, when we combine these two, obviously dia tak cancel out Ni dia tak cancel out Dia bukan straight line. Kalau straight line tak apa, dia cancel out sebab dia straight line, dia cancel out. Okay, this is not straight line, this is angle. So when these two combine, dia akan ke sini. Okay. Ini memang vector lah. Okay, so when these two combine, you akan ada net dipole moment. So this is what we call, so ni done. Okay, so we have this net dipole moment. This is the net dipole moment. So we have the net dipole moment, therefore automatically the H2O molecule is polar. Right? Yep. Done. Okay, alright, Alhamdulillah. Okay, so that's all for today's lecture. Okay guys, so please make sure that you cover all of this starting from Vsepr until polarity. Okay, so this will be coming out in your quiz.